Dear student, in this lecture, I'm going to discuss with you how to find the canonical cover, right? So before we start of this topic, first we should know uh, what is the algorithm, right? So here I'm just explaining the algorithm or points related with the canonical cover, right? So the first point is, if a set of FDs is given to you, then convert each FD into simple FD. Each FD into simple FD, right? So each FD into simple FD, what does it mean? Does it mean that like if the FD is given to you like this one, A determine BC, right? Then uh, write it like this one, A determine B and A determine C. That means in right hand side, the symbol single attribute over there, right? For all FD. The second is remove remove extraneous attribute from the left. Extraneous attribute, extraneous attribute from the left. Attribute from left. What does it mean? Does it mean that suppose A determine B is given to you and AB determines C is there, right? Then uh, extraneous attribute from the left means if it is possible, then remove extra attribute from left hand side of the FD, right? Like over here, A determine B is there, so in the left hand side only single attribute, so no need to do anything. In the second FD, A determine B, A B determines C. In this FD, see, in the place of this B, you can write A because A determine B is there. So this you can write A A A A determines C. So you can write this like this one also, A determine C. So in the place of this B, you can write A, this one. But here only two FDs is there, then simply we can say, okay, in the place of B, we can write A, so I can write A determine C. But what is the method if the number of attributes given over there? How we identify which attribute we have to remove? Now, the second method is what you can do. You can take the closure of this one or this one. Like here on the left hand side, more than one FD. Now, then what you can do, find the closure of A and the closure of B, right? And if in the closure of A and in the closure of B, from here, closure of A, what is the closure of A? The closure of A is AB. What is the closure of B? The closure of B is B only, right? So in the closure of A, B comes over here. In the closure of A, B comes over here. So you can remove B from here and directly write A determines, right? So this is the second step. And the third step is then find the non-redundant cover of F. Non-redundant cover of F we have already discussed in last lecture. Non-redundant uh, cover of F, right? So what I'm doing over here, I'm just trying to solve uh, this question over here, right? So yes, so here I'm just starting to solve this question. So the first step is, in the first step, the FD is given to you, A determine BC, E determine C, D determine AEH, ABS determine BD. So the first step is convert each FD into simple FD. Simple FD. Simple FD means on the right hand side single attribute. So A determine B is there, BC is there, so you can write A determine B, A determine C, E determine C, D determine A, D determine E, D determine H. Right? So on the right hand side single attribute. Similar for the ABH, ABH determine B and ABH determine D. So I hope up to this there is no problem to anybody. What happened in the first step? In first step we just convert each FD into simple FD, right? In second part, the second part of the algorithm says remove extraneous attribute from the left. So where the single attribute over there, like over here, A determine B, A determine C, E determine C, D determine A, D determine E, and D determine H. Here there is no problem, but here A, B, H determine B. Here what happened? From here you can see, yes, A determine B, so you can write A in the place of this B. Yes, but just apply the second method. The second method means the closure of A, B, and H. So when you find the closure of A, when you find the closure of B, when you find the closure of H, what is the closure of A? In the closure of A, B is there. Yes, B is come over there. But in the closure of A, H is not comes over there, right? And in the closure of B, simple B is there. In the closure of H, simple H is there. The closure of H, simple H is there. So from A, B, H. So what happened? You can write A in the place of this B. So this FD, this FD implies what? AH determine B. AH determine B. Because in the place of this B, you can write A, so AH determine B. Similar for this one, ABH and determine D. This you can also write AH determine D. Right? So this is the second step. In third step, what you have to do? You have to find the non-redundant cover of F. Non-redundant cover of F. So the same process that we discussed in previous lecture, you have to find the non-redundant cover of F, right? So what method we discussed over there? For each FD means like for first, for A determine B. A determine B, the G is what? The G is A determines C, E determines C, D determine A, D determine E, D determine E, and D determine H, right? Then find the closure of A, find the closure of A. So like this, find the non-redundant cover of F, and when you find the non-redundant cover of F, then in this case, I think this one, okay, just let us check this one. A is determine B. What happened? All these are the non-redundant. Now let us check A is determine B. So for AH determine B, for AH determine B, what is G? The G is A determine B and A determines C, E determines C, D determine A, D determine A, and D determine E, D determine H, D determine H, and AH determine determine D. Right? Now what you have to do? You just remove this set of this FD AH determine B. So you have to find the closure of AH. Right? So when you find the closure of AH with the help of this set of FD. So AH, okay, AHB, or AHB, okay. A is there, so C, yes, okay. E is there, E is there, no, it's not there, D is not there, D is not there, D is not there, A, H is there, so D comes over here, and if D comes over here, D, A is there, D, E is there, all the attribute over here, all the attribute over here. And in non-redundant cover, we already discussed, if the closure of AH comes on attribute of the relation or B, sorry, attribute on or B, then in that case what you can say, yes, this FD, this FD AH determine B is non-redundant cover of non-redundant, is redundant, right? So if AH determine B is redundant, now you check, for the FD AH determine D, right? So when you check for AH determine D, then what happens? For AH determine D. So for AH determine D, then what happened? Um, the G is what? G is A determine B, A determines C, E determines C, D determine A, D determine E, D determine H, D determine H, and AS determine B is redundant, so no need to take it. And AS determine D, AS determine D, okay, AS determine and D, right? Now Find the closure of AH. Find the closure of AH because you are removing from AH determine D the AH. What is the closure of AH? AH. So AH, okay, A is there. So B is there. B is there. D is not there. D is not there. D is not. So in any case, D is not comes over here, or in other words, you can say the whole attribute is not over here, okay, over here in the closure of AH. So in this case, you can say so. So AH determine D is not redundant. AH determine D is not redundant. This one, this AH determine B, this AH determine B, this is redundant, but AH determine D is not redundant, right? AH determine D is not redundant. So, so here you can write the solution. The solution, how you can write? In solution, you can write so. So canonical cover, canonical cover of F is, yeah, what? A determine B, A determine B, A determine C, E determine C, D determine A, D determine E, D determine H, D determine H, and AH determine D, right? So whenever you have to write the canonical cover of F, these are the steps. The first step is convert each FD into simple FD. Second, remove extraneous attribute. And third, find the non-redundant cover of. Because when you do any changes, see what happened here. Here you do the changes, na? So whenever you do any changes, then you have to check is that redundant or not redundant, right? We just check over here, then we get the AS determine B is redundant. So okay, if AS determine B is redundant, but AS determine D is not redundant, right? So I hope now all of you understand the method to find the canonical cover of F. Thank you.